guys, welcome back to our channel. This is Remy from Do and Learn. So today we'll be learning about Daemon Threads. So let's get started. So Daemon Threads are threads in Java that provides services to the user threads which runs in the background. So Daemon Threads are not equivalent to user threads or system defined threads. So they are some light level threads which runs in the background, and the main usage of these threads is to support the other user defined threads. So it is considered to be a low priority thread which is used to perform tasks such as some basic lower level tasks such as garbage collection or no file closing or object deletion, which is of course equivalent to garbage collection, and so on. So in Java, every thread has got its own priority, and you know that when a thread has got a higher priority, the possibility of that thread executing faster compared to other threads are really high. But in contradiction, this daemon threads has got very low priority compared to all the other user priority or user threads. So Java Virtual Machine is the main component which terminates all the threads automatically. We know that. So whenever we create each and every thread in Java, JVM takes care of winding up of those threads or execution of those threads, and once the threads gets over or once the process gets completed, so Java Virtual Machine is the thing that terminates this thread automatically. Whereas JVM will not terminate if any user thread is still running in your program. It's like JVM will not close your program when you have a user thread still existing or running. But on contradictory, JVM will terminate a program if all the user-defined threads are over. I mean, the processing time and the process of all those user-defined threads are over. But still, if some of the daemon threads are still running, even at that situation, JVM will not bother about the current situation, and still it will terminate the program. The meaning is that the daemon threads are having very low priority, or we can call it as like equivalent to nil priority. Even JVM doesn't wait those threads to over or get over, or JVM doesn't wait for those threads to get over before terminating the whole program. So just let's take a view on the difference between these daemon threads and user defined threads, or we also call it as non-daemon threads. The major difference comes here because of this JVM. The first one, daemon threads are created by the JVM, whereas the user threads are created by the user application or the user himself, whereas the JVM does not wait for the completion of a daemon thread. So as soon as all the user threads gets over, JVM will exit your program. The same thing when you have a user thread, JVM will of course wait for the user thread to complete its execution. Whereas the third point says that of course the daemon threads are of low priority and user defined threads are of high priority. And mostly the use of these daemon threads are like for typical background tasks which are not at all critical for the core working of your program, whereas your user defined threads are more or less equal to the core application task what you create in your program. And the life of a daemon thread depends on the user threads. So if a user threads are not at all there, then there won't be any daemon threads to serve those user threads. Of course, each and every program has got many user threads, and we need some daemon threads to serve them. And here we have the different methods that are defined in Java for creating this daemon threads, or checking whether a current thread is daemon thread or not, or even converting a user defined thread to a daemon thread. So the first main function that will help us to convert a normal thread to a daemon thread is set daemon, and inside the brackets we pass a boolean value as a parameter. If the boolean value is true, of course the thread will be converted as a daemon thread. If the boolean value is false, it won't be. And the second main method which is used here is daemon. So this method will return us a boolean value true or false based on whether a thread in which this method is attached is a daemon thread or not. So in simple terms, this is daemon method checks whether a thread is daemon thread or not. So having this concepts in mind, let's go for a simple program. We create them and we'll try to execute them. Let's get started with the program. So let's first create a simple class which can demonstrate this concept for us. So the demo, let me extend the thread class here. So this will be the class which will be a threaded class for you, and then we will have a main class. So let me call this as, okay, we will call this as the demo. First, this will be the main class for us. So let me rename the previous class. So let me call this as Daemon thread. Okay, that seems fine. So let me have a main method, public static void main. Okay, and since we are using the threading concept, this throw interrupted exception. So let me have this. So the main method is ready. So in order to perform threading, we need to have a run method. So let me create that, void run, and let me create another method, a simple method. So let me call it as simple. Okay. So inside this, let's have a try catch mechanism. It will catch the interrupted exception required. Let me have a small printf function, println function, dot out dot println. Not interrupt. Let me print the stack trace if required. Yeah. So hopefully that is done. So in your try, let's print something. Okay. Out dot println. So let me call this as executing child thread. Okay. And let's make this thread to sleep for a second. Sleep for like 1000 milliseconds. Okay, that's fun. Now let's call this method from this run method. So I'll be using a while loop. So let's say this while loop runs unlimited time. So we will pass true value here, and let's call this method here. That's it. So when we execute the run method, it indirectly calls the simple method which keeps on running for unlimited times with the gap of 1 second. And let's say we create an object for this thread program. Okay, so the class name is Daemon Thread is dm equal to new thread. The object is created. Now before I start the child thread, so okay, anyhow, let me start the child thread. So this method calls your child thread, and let's say your main thread sleeps for like 5000 milliseconds. So it's like 5 seconds. So every 5 seconds your child thread should work. After that you will put an end to the system. Main thread exiting. Okay. So once I'm done for 5000 seconds or like 5000 milliseconds, your main thread will execute and it will stop after that. Meanwhile, for every 1000 milliseconds, your child thread will execute. So let's check this one out. Java C, Java. Okay, it says void type not allowed here. Okay, so let me do one thing. I'll call that separately. Let's try again. Without semicolon. Yeah, I hope it's fine. Let's go for the execution. As you see, your child thread is first executed for 5 times with a gap of 1 second. Then comes the main thread, and then main thread exits, but still the child thread is continuously executing, because the reason behind this is the child thread runs inside a while loop which is unending. So this child thread is also created by a user. So JVM will not exit your program until this user defined thread is closed. And we have not defined any code here to close this thread. So let's go back. We'll stop this for stopping it because while loop is unending here. So let me modify this small this program with the help of a daemon thread. So let's convert this child thread to a daemon thread. So what we do, set daemon, and the parameter should be true here. Okay, now this thread called as DM is converted to a daemon thread. Now let's see what happens. So the thread executes for 5 times, then comes the main thread, and once the main thread exits, the program exits, because as of now this part, the child thread, is a daemon thread. So since it's a daemon thread, it's very low priority. So once your main thread is terminated by a JVM, you don't have any other user defined threads so that the JVM should still be working. So since we don't have any user defined threads and only one daemon thread was running, and the daemon thread's priority is really low, now the JVM exits the program. So that shows you the difference between the daemon thread and a normal thread. Now let's check whether any thread is daemon thread or not. So what we can do is, so this is where I start my child thread. So maybe I can put a printf function here. Is it a daemon thread? Just a question. And then here we can add up like this dot is daemon is the function which will help us to identify whether that's a daemon thread or not. At the same time, we can check whether your main function is a daemon function or not. So maybe I can create it over here and call it as thread dot current thread, that's daemon or not. So let's check it out. Even we can put this same code also in the above function, but anyhow I have this keyword that means the same. I can replace it like this. So let's check it out now. Okay, as you see, first it says it's false, then it's true. So likewise, so this false is for your main method, I mean the main thread. Then comes your execution of your child thread, which is your daemon thread. It says it's true, and then it executes the child thread for 5 times. So every time when it executes the daemon thread, it says it's true, and when it executes the normal main thread, it says it's not a daemon thread because it's false. So likewise, once all the execution is over, when the main thread is getting exiting, when the main thread exits your system, so thereby JVM closes the whole program. So hope that's clear. So thank you for watching this video. If you have any queries, please feel free to text us or comment in the comment section. Subscribe for our channel. Let's see in the next video. Thank you.